Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Great. Today we're here to talk about a managed identity incident. We had a managed identity for Azure Resources incident that impacted the Australia East Azure region. This was on the 12th of July, 12th of July UTC for our Australian colleagues and customers. That would have been on the 13th of July. And that's why we've gathered a couple of relevant engineering leaders to help explain the incident and our learnings.
Super, and it gives me great pleasure to introduce our engineering leaders. They're both from the identity team. We have Oren Meltzer, our Principal Group Engineering Manager. Welcome, Oren.
And we've also got Ashok Chandrasekaran, who's our Principal Group Engineering Manager for one of our internal key management services.
Super, thank you very much. To kick it off, Oren, can I turn to you first? Before we get into the actual incident itself, could you help me and our customers understand what is managed identity and how does it all work and why is it so fabulous?
Sure, absolutely. Historically, one of the things that everybody needs when they build a service is they need to be able to authenticate between that service and other dependent services. So you might have an Azure virtual machine, and you need to authenticate to an Azure storage account, a Cosmos DB, a SQL database, any number of other types of resources. Historically, the way people would do that is they would use some sort of secret to manage that connection. And so you would have a connection string or a password or certificate of some kind, and then you would have to manage that. And those kinds of keys have to be rolled over from time to time, and which presents an availability risk. It turns out, from what we've heard from our customers and even seen from internal services historically at Microsoft, rolling over keys is one of the leading causes of outages, as you'll see also with this one. And the fewer keys anybody has to manage, the less likely they are to have an outage like that. In addition, everybody's paying a lot of attention to security these days. Any kind of secret that you may have is an opportunity for a secret to be leaked, taken, accidentally put in source code, stolen. And so as Azure, we're working on building a set of capabilities that enable services to run without any kind of credentials or secrets at all. And managed identity enables that, both for internal Microsoft infrastructure and for our customers. At a high level, the way that it works is a managed identity is created or assigned to a compute resource in Azure when that resource is created. So for example, you provision a virtual machine, you can assign an identity to that virtual machine, and then you can give permissions for that identity to be able to access a resource, like a storage account. And effectively then you write code that runs on that virtual machine and can access the storage account inherently based on the identity that it has. So if that same code runs on a different virtual machine, it wouldn't have access. And there's no credentials to manage, nothing to roll over, anything like that. And the way that that works in the back end is the Azure infrastructure itself knows the identity of the virtual machine that runs. And virtual machine is just one example. All of our major compute platforms in Azure, from Kubernetes and Service Fabric and any number of others, all support this. And the underlying infrastructure knows the identity of your compute and basically is able to fetch what's called an access token from our identity system for you and give you the token that you need to access the resource that you have access to. And everything happens completely seamlessly with no credentials, no secrets to manage at all. And so we highly recommend our customers to use managed identity. And also internally within Microsoft, we've been moving more and more of our infrastructure pieces of Azure to use managed identity themselves so that we can get rid of our own secrets in the company. And we've gotten rid of a very large number of secrets over the last few years doing this. So that means that even as a customer, if you've never heard of managed identity is almost certainly working for you to make your scenarios work. And also in this particular case, managed identity might have caused an impact for you.
What a great overview of managed identity. I like the way you explained it there. I like that I can walk up to my car and I don't have to have a key on me because it knows who I am. This is the same kind of thing for IT services here. So that's good background, Oren, but now let's pivot to 12th of July. What did customers experience? What was the pain caused by this outage? And what went wrong behind the scenes?
Sure. So on the 12th of July, for Azure Resources hosted in the Australia East region, they would have experienced an outage if they were attempting to manage their managed identities. So things like create, update, or delete, or if they were creating Azure resources that relied on managed identities. So for example, if you had a virtual machine, that virtual machine was configured for a managed identity, and you tried to create a new one from, say, an ARM template that you have, then that would have failed during this time. Existing resources that were receiving existing tokens for managed identities were not affected by this outage. In terms of what happened, ironically enough, this is related to secrets management internally. As much as on the managed identity team, we champion the removal of secrets at Microsoft, within our own system, we cannot depend on ourselves. That would be a circular dependency, and that means that we need the ability to have secrets. And so managed identity as a service exists in every region where Azure exists. And we have an underlying storage infrastructure that stores information about identities. So that's things like which identities are assigned to which machines and how do those relate to the permissions they have, the service principal directory objects that they have. And we have been working on upgrading the way that we manage the security of those storage accounts. And so as part of that upgrade, we were moving from an internal system where a manual human presses a button for the keys to that storage account to roll over to an automatic key management system. This was a one-time migration, and we performed it in a number of Azure regions previously without issues. However, in Australia East, this migration was done on the server side where the storage key was rolled over before the required compute of the managed identity service had been deployed that had the build version that understood how to deal with those keys. As a result, when that key rollover happened, the existing compute was not able to authenticate to the underlying storage, leading to an outage. However, as I mentioned before, we have many levels of caching to ensure that existing Azure resources continue to function, even if the managed identity service doesn't work. Those layers of caching kicked in, and we're able to protect the existing scenarios. But because our underlying storage didn't work, anything that required writing to a managed identity or reading from something that wasn't able to be cached was impacted.
Super, thank you, Oren. It's fascinating to hear about how you don't take a dependency on yourself, and you have a key management system to roll over as well. I know it doesn't completely eliminate things, but it definitely reduces risk for customers not having such a large surface area of having to rotate keys, but using managed identity. One of the things that caught my interest in the PIR is that, yes, we had an issue, and yes, it was in Australia East, but there was also some sort of impact to Australia Southeast. Was this a multi-region event?
This was not a multi-region event, so let me clarify that. In Azure, every resource is homed in a particular Azure region. So when you go to Azure Resource Manager or in the Azure portal and you create a managed identity or you create a resource with a managed identity, that resource is homed in a particular region. If the identity is created in Australia East, then it is homed in Australia East and it is stored in our storage for Australia East. Normally, our services are built to be redundant and resilient to both a zonal and a regional incident. What I mean by that is we have the ability to fail over automatically any request that fails in multiple layers. So the first layer is if a request fails in one availability zone for regions that are zonal, it will be automatically retried by our internal system in a second zone. The second one, and then that zone may be marked as unhealthy by our internal system and traffic is routed directly away from it. The second resilience mechanism we have is if multiple zones in a region are having failures, we have the ability to mark all of those as unhealthy and have the traffic seamlessly fail into a second region. So in the case of Australia, the failover pair for Australia East is Australia Southeast. This can protect against many kinds of outages. However, in this case, the underlying storage infrastructure is shared between the regions and is accessible from both regions. So there's effectively a copy of the data that can be read in Australia Southeast, and we also have the ability to fail over our write capability so that we could also be writing in Australia East. But unfortunately, in this case, the key that is being used to authenticate to that account, because it's one account with a failover capability, is the same key. And that means that our normal failover mechanisms of both failing into a different zone and failing into a different region were not effective in this outage. What that means is that if you had a resource that was homed in Australia East, you would have seen impact. If you had a resource that was homed in Australia Southeast, you would not have seen impact. But we were not able to fail over into Australia East to mitigate the incident.
Got it. That's much clearer. I can understand now why we mentioned Southeast, even though that you weren't directly impacted if that's where you were housed there. So, Oren, can you help us to understand during the incident itself, how did our people and systems respond here? Would you talk us through how we initially detected the incident, how we went about investigating it, and ultimately how we were able to mitigate it?
Sure. So as with any outage or incident in Azure, we always do a post-incident report, and I know that we've published our public one, and we do an even more comprehensive deep dive on these things internally. There was good and there was bad in this incident, to be honest. The good was our own telemetry. We detected this very fast. An incident fired on our on-call engineer, I believe, was within something like 6 minutes after the first failures started occurring. We were on a call right away. We involved our key engineers that we needed to involve, and we knew right away that it was related to this key rollover because we knew that we had just performed this key rollover in Australia East. Unfortunately, despite the fact that we brought on a large number of engineers, experts in a large number of areas, we misdiagnosed the cause of this for a period of a few hours. Because we were moving into a new key management system and we knew that we had just done that, we believed the problem to be with the new key management system. And we spent a good deal of time trying to debug the new key management system, understand why the underlying storage wasn't accepting our key, why the key must not have been propagated properly through the system, that sort of thing. It took a number of hours and a number of attempted mitigations that didn't work for us to realize that we had the root cause backwards. The actual root cause was that in Australia East, we had an older version of our service running that wasn't using this new key management system at all. It was using the old key management system. And by rolling over the key, we effectively desynced the key that was being used from the key that would be accepted by the storage system. And that's what led to the outage. Once we realized this, we were able to push a configuration change fairly quickly and drive mitigation after that.
Magic, thank you very much, Oren. One of the things that we'd like to do in these incident retrospectives is talk about customer resilience. Is there any guidance? Is there anything customers could have done? Is there any high availability or disaster recovery that customers facing this issue during that time could have had, or were they stuck?
So I want to be careful, of course, not to blame any customer or anything about their topology for this. If you build your resources on Azure in any zone and in any region, it's reasonable to expect that your things are going to work. And I personally will apologize on behalf of my team and on behalf of Microsoft that this outage occurred. That being said, there are a number of steps that customers can take to increase resilience against an outage like this or any number of outages or events that may occur. We have a lot of public documentation on that, but one key thing is to spread compute resources where possible across availability zones and across regions. In general, there are many kinds of events that can happen, from logical failures like this one to physical events, networking events in Azure regions, all the way down to natural disasters that impact our data centers, wherever they may be. And in general, the more you have the ability to provision your resources in multiple zones and in multiple regions, the more you have the ability where possible to be present in multiple zones and multiple regions, the less likely you are to be impacted by an event like this.
Got it. That's a great way to describe it. If your ship is big enough, then you can handle the different waves. And in this case, we're talking about straddling across multiple regions as one way to help there. So that's a great overview of the managed identity space. Probably a good time for us to bring Ashok in. Ashok, I'd love to understand. I know Oren's representing managed identity. You're representing our kind of internal key management system. What role does your team play here, and how does it kind of interact with the other services we've been talking about?
Oh, you're on mute, Ashok.
So thanks, David. Yeah, my team owns a secrets management system that's used by Microsoft and also by third-party customers. Like, you may all be familiar with Key Vault, which is one of our public-facing offerings. We also have an internal secrets management service, which is managing keys, certificates, and credentials that are used by our Azure Fabric itself. Like, you can think of all the compute fabric, the networking fabric, and the identity fabric, on top of which Azure runs, uses this internal system, which is responsible for both managing the keys, their life cycle, and also to distribute them. So this is the system that managed identity was using. And we had some improvements in the system for compliance and auto rotation, which would have enabled managed identity to be more secure at the infrastructure level. And this was what the migration that was being done by managed identity.
Super. Ashok, upon reading the PIR, there was one line that caught my mind. Was it about human error, or was it an operator error? In general, the way I think about things is that we know humans are going to make mistakes. We're just designed that way. And so we create systems that prevent humans or minimize the risk of human intervention in this. Could you tell us a little bit more about what you're doing with your key management system to harden it and to add guardrails so that we don't allow humans to make mistakes, because then it really becomes a system issue, not a human issue?
That's an excellent point. So one of the things part of this migration was it was a multi-step process, which service teams had to perform certain operations and then coordinated deployments and then go update some tool chains in their systems to ensure that the migration was smooth. But then given that it was a multi-step process, they needed to exist certain guardrails within the system that would have prevented service engineers or like engineers on any team from running into edge cases or performing unsafe operations. And that was one of the biggest learnings out of this thing was like those guardrails, the related monitoring and dashboards that service engineers could use to monitor the health of their systems and to safely guide them through the migration process was missing in this case, right? And so we are definitely taking that learning. And as part of this PIR, what we're doing is we're actually pausing internal migrations for service teams to this new platform until we put the guardrails in place and the toolchain updates are made so that teams can safely migrate from one system to another without having an impact on their services.
Well, that's great to hear. I'm glad that there were kind of learnings and repairs there, and to make sure that service teams are kind of staying within how the tool should be used, and make sure that they don't make mistakes like that. I want to pivot towards customer communications. Fortunately, my co-host here runs the Azure communications team. Sammy, how did we do? Did we keep customers up to date during the incident? Do we have any learnings or improvements from a comms perspective?
Well, the issue started just before 1 o'clock UTC. Our Brain, which is our automatic communication system, was communicating to customers saying, hey, you've tried to create or delete or scale, conduct this operation and you failed. It's an us problem, not a you problem. And Brain was communicating in batches. It started around just half an hour after the incident started, and it was communicating. While we knew what the incident was straight away, during the fog of war and getting information from one place to the other effectively meant that we didn't communicate that this was related to a deployment until about 3 a.m. UTC. By kind of just about 20 past 4, we went to the status page. Now, we communicate on the status page for a few reasons. One of them is if the portal is down and customers can't log in and access service health. The other one is if we don't know who's impacted, and it could be an ISP or a routing issue. And lastly, because if there is an outage that's so big and an impact is growing and we can't keep up with communicating to customers, we'll go to the status page so that we don't introduce delays for customers. As this one was becoming multi-service, because there, as Oren mentioned earlier, there are so many services now that are onboarding to manage identity. So you might have found we saw VMs, we saw scale sets having issues, we saw Service Fabric, Databricks, Kubernetes. They're all experiencing issues. And then I think somewhere, and Brain was communicating to those customers to say, hey, those operations are failing. When we started to understand or perhaps misinterpret that Australia Southeast was also impacted, this now became a multi-region event. And we say, hey, look, multi-region events, typically they're going to be broad and we'll communicate on the status page. So I go back to, I think, Brain sending out those different tracking IDs because it does it differently. It's not great at correlating. And I think if I'm being honest with you, this communication shouldn't have gone on our status page. We should have remained targeted behind Azure Service Health because we were able to communicate to impacted customers in a timely manner.
Got it. And as Oren described, this wasn't actually a multi-region impact because of the specific way that we understand that configuration. So thank you for running us through that. And thank you to Oren and Ashok for explaining to us what happened and what we learned from it. It's cool that we can come together here and talk about, obviously outages happen. We like to say outages are inevitable, but impact doesn't have to be. And so Oren ran through some of the recommendations that customers can use if they want to harden their kind of the way that they use managed identity. And then Ashok covered the internal repair items that we've got for our internal key management system to make sure that our internal service teams are kind of using that as best they can. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure Well-Architected framework.
To ensure that you get posted incident reviews after an outage, and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
we really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.